Okay, good morning, students.
Good morning, doctor.
Morning.
Good morning.
Are you well prepared?
Yes.
Yes.
Okay, please raise your hands so I can pick up. To start with the solutions, please. Malak, good morning.
Good morning, doctor.
Let's start with the first exercise, please.
Yalla. Which is true concerning RNA and DNA? The sugar present in both acids is the same. أكيد لا false. They have the same purines. Both are double-stranded. They have the same number of nucleotides. They have the same purines اللي هني A and G. B.
Okay, good. Malak, let's start from A, please. The sugar present in both acids is the same. Correct that, please.
No, بالRNA it's ribose sugar. In DNA it's deoxyribose.
So at which position they differ?
In number C DNA عندهم 5' C بالRNA 1C.
Say that again, please.
DNA the nucleotide is attached to 5' C, whereas بالRNA it's attached to 1C, 1' C.
No, be careful. No, it's not that.
Okay. Both are pentose, yes, بس بالRNA في عندي hydroxyl OH, whereas بالDNA عندي only H.
At which position?
الRNA at position 2' C.
Yes.
وحتى الDNA at 2' C، بس هون في عندي hydroxyl، هون في عندي hydrogen only.
Excellent. Do they have the same group at the position C3 prime?
I didn't understand your question. Can you repeat it, please?
Yes, I will repeat. Do they have the same group at the position C3 prime?
Yes.
What is that group?
OH.
Excellent. Okay, you started saying that whatever is attached to the 5' or 1', note that whatever is attached to the C1' is the nitrogenous base.
Yes.
And we have it either N9 or N1, but it's always linked via the N-glycosidic bond to the C1' of the sugar.
Yes.
And on the C5' always had the phosphate.
Yes.
Excellent, Malak. They had the same purines. Okay, what about their pyrimidines?
Pyrimidines هني CUT. CU it is for DNA. No, sorry. CT it's for DNA, and the U C هي للRNA.
Okay, so they do share one pyrimidine, that is the
C.
cytosine. Okay, good. Both are double-stranded.
No. RNA it's single-stranded. DNA it's double-stranded.
Perfect. D?
They have the same number of nucleotides. No, أكيد لا. We don't know أصلا the number of nucleotides حسب الجين.
Yeah, okay, but if they will differ in their number of nucleotides, how would that be basically?
According to the stop codon.
No, that has nothing to do with the stop codon.
Yes.
Actually, this is related to C.
Yes.
Okay, so?
يعني according للstrand إذا هي double stranded حيكون يعني DNA أكيد number of nucleotides هو أكتر. RNA because it's single stranded number of nucleotides هو أقل.
يعني basically إذا بعطيكم sequence of DNA أنا مش تزقى sequence بدها تكون هي double stranded so that the number of nucleotides in the RNA theoretically should be equal to قد ايه يعني تقريبا.
half number of nucleotides عند DNA.
Excellent, Mala. Well done.
Thank
Two.
you.
مين معي هلا؟ Let me see your hands, dear students. You are well prepared, and that's a very good beginning. Alhamdulillah. Sarah.
Yes.
Concerning DNA properties, which proposition is true? Adjacent nucleotides are linked by hydrogen bonds. False. Each purine is base pair with a pyrimidine. True. The 5' end of the DNA chain has a OH group. False. During transcription, RNA polymerase reads 5', 3' DNA strand. Also false.
Okay, Sarah, let's
Yes.
start from the beginning, please. Adjacent nucleotides are linked by hydrogen bonds. Make that correct, please.
By phosphodiester bonds.
Okay. Each purine is base paired with a pyrimidine.
Yes.
Yes, obviously
True.
this is correct. The 5' end of the DNA has a
Phosphorus group.
phosphate.
Phosphate, yes.
Phosphate.
During transcription, RNA polymerase reads the DNA strand من 3' to 5'.
Well done, Sarah. Omar.
Yes. Concerning transcription, which is true, the synthesis occurs in 3', 5' direction, so that the template strand is read in the 5', 3' direction. False. The template strand is also called the sense strand. False. RNA polymerase can transcribe the same gene many times. That's true. RNA polymerase needs an RNA primer to initiate RNA synthesis. False.
Okay, Omar, let's start from A. Make that correct, please.
Okay, it synthesizes 5', 3' direction, and it reads 3', 5'.
Good. B.
Okay, the coding strand is called the sense strand, not the template.
Okay, let us assign the template strand all the other designations, please. The template strand is also called the
Transcribed strand.
or. Okay, complete.
The template strand, transcript strand, or nonsense.
Anti-sense. ما شيء اسمه nonsense بالstrands. This is anti-sense. Right? عمر. بدل ما نقول nonsense, we say anti-sense, okay? Omar, are you still there? Okay, I think I've lost him بالinternet connection or something. Anyway, students, the template strand is also called the transcribed, the anti-sense, or the non-coding strand. RNA polymerase can transcribe the same gene many times. Yeah, that's correct, to produce many transcripts. So that's an amplification process. RNA polymerase needs an RNA primer to initiate RNA synthesis. This is not the RNA polymerase that needs RNA.
Sorry, but my connection was lost. I joined.
Yeah, I've guessed so. RNA polymerase should be replaced by شو يا عمر? RNA polymerase should be replaced by
DNA polymerase.
Well done, Omar. Thank you. Hassan or Hawra?
Sorry,
right?
but can I ask
Yes,
number 3
doctor.
something?
Go back to the recording, Omar. Okay. Hawra,
Yes.
are you ready for 4?
Which of the following results is consistent with the Griffith experiment? A. Inject R strain, mouse dies. False. B. Injected the heat-killed S strain, mouse lives. Yes. True. C. Injected mixture of heat-killed S strain and live R strain, all mice die. False.
Okay.
Heat-killed R strain.
What about D?
False.
Okay. Hawra, let's start from A, please. Injected R strain mouse dies because this is false.
It's not capsulated. Not virulent.
Yeah, okay. So correct that, please.
Injected S strain mouse dies.
or injected R strain mouse.
Mouse live.
Okay, this is correct. So there's nothing to add. C. Correct that,
Injected
please.
strain and no. If we inject only live لا هي مش كل المايس داي.
Okay, so make that correct, please. Injected mixture of heat-killed
يعني injected mixture of heat-killed strain and live R strain. Some of mice die.
Excellent. Excellent, because the transformation yield is never 100%. Excellent, Hawla. D.
No, when we have the live A strain, mouse will die.
All the mice, right?
Okay.
Okay, so mouse dies because it's about the living S that we're talking about and we are worrying about here. Yani, if we have here the concept of mouse lives, كمان هنا we have to be reluctant about mouse lives. Okay, do they live? عندنا ال S living هون, so we have them dying.
No.
Okay, we have the pathogenic S strain.
Yes.
If a transformation will happen from R to S, maybe some of the mouse will die. Okay, so
Yes.
in any ways, this is wrong, and we've corrected it. Good.
Can you please repeat part C?
C or D?
C.
C.
Yes, please.
Yeah, she corrected it. She said that not all the mice die. And this is what we've covered actually when I explained it. If you was careful about how I explained it, actually if you go to the Griffith finding رح بتشوفي انه حكينا وقتها انه في عنا some of the R will be transformed. لما عملنا every ماكلورين مكاري كمان مرجع مرق معنا بس اشتغلوا in vitro ما اشتغلوا على مايس لقوا تحت بالترانسفورميشن اذا بتطلعي على الريزلتس كيرفولي بدكم تنتبهوا كثير منيح للفيجرز وللليجندز وللديتيلز رح بتشوفي انه كاتبين تحت living R cells and some of the living S cells. Okay, so عندك both types. You don't only have one type. Okay, so some of the mice will die by being injected with the S. يعني مش كل الماوس أو مش كل المايس will be injected with S. Some of them will have the R type. اللي عندهم R type survive. Batul?
Yes, doctor.
Hi.
Chargaff law is not applied in the following cases: DNA replication, during replication, false; mRNA, true; DNA during transcription, false; double-stranded DNA, كمان false.
Make it correct, please, Batul.
Yes? I didn't hear you.
Make it correct. Why is it that A is false?
A is false لأنه DNA during replication بتكون هي double stranded وتشارجاف بيقول إنه A بتساوي T والG بتساوي C فيعني هي يعني applied.
Applied. Complementarity relationship is applied.
Yes, بالmRNA it is single stranded so it is not applied.
And how is it applied with transcription, during transcription?
During transcription بس يكون عم يعمل transcription للtemplate بيكون عندنا two strands
Of
وبد DNA double stranded كمان هن double stranded فبتكون ال A بتساوي T يعني في complementarity.
But do we have double-stranded DNA during transcription?
Double stranded DNA no بيكونوا unwinded.
What is it? Double-stranded عم تقولي شو هو double-stranded هون؟
as a template مع ال RNA synthesized.
Yes, so this is a heteroduplex. So we have one strand of DNA, okay, and we have the hydrogen bonds between DNA and RNA. And while the RNA polymerase is incorporating these nucleotides of RNA, it is respecting Chargaff's rules. But this is transiently during the elongation or during the initiation. But when the RNA is released at the end of the transcription, خلاص, it becomes a single-stranded, right?
Yes.
Good. D.
Yeah, DNA is a double strand يعني في complementarity between A and T with G and C فtrue يعني Chargaff
Very
law
good.
دكتور يعني C correct ولا لا؟
عم بقول لك is not. It is applied.
ايه بس ما فهمتش انه كيف قلتوها انه applied.
لأنه أنت في عندك RNA polymerase عم تعمل السينثيسيس، عم تقرا template and it respects شو هن البيزز الموجودين على التمبليت against which عم بتحط. عم تقراهم وعم تعمل على أساس complementarity relationship. So it is respecting Chargaff law, but this is transient. This is بس هي عم تعمل ها transcription. When it's done, that's gonna be released. So خلص بصير single stranded.
Okay, thank you.
Dima?
Yes, good morning.
Good morning.
Concerning the quantity of DNA molecules in a meiotic cell, which is false. In G1, the quantity of DNA molecules is 2N. It's true. لأنه in G1 بيكونوا 2N chromosomes, each one عندها وحدة chromatid. In S, the quantity of DNA molecules is 4N. True, because they are 2N. Each chromosome has 2 chromatids. In G2, the quantity of DNA molecules is 4N, كمان true. In M1, the quantity of DNA molecules equals N. No, because their number is N, but they are double. يعني كل وحدة 2 chromatids, يعني 2N.
Very good. أنت هيك عملت الأناليسيس الكومبليت أناليسيس. Complete analysis. هلا لاحظوا students إنه how they represent the DNA molecules بهذا الإكسرسايز منا هالقد accurate، لأنه المفروض نحن نشتغل على C representation بالنسبة لل DNA molecules مش الآن. هي أكثر للكروموسومز. بس إنه they fixed هذا اللي أعطيتكم إياه نوت مرة، قلت لكم بس اشتغلوا بالإكسرسايز مثل ما هو ماشي، بيشتغلوا معه. designation كانت على أساس N representation، so okay fine نشتغل على أساس الآن. يعني ما مفروض إنه نحن نتعقد من هيك designations، نمشي مع الإكسرسايز إذا نحن فهمانين نقدر نخلص حالنا. Batul. That was Batul, right?
No.
Dima,
sorry. The last one, correct that, please.
It's 2N, لأنه عددهم N, بس 2 chromatids each.
Okay, Dima, I will ask you to reconsider this in terms of chromosomes so that we have the number of chromosomes, and keep it in presentation, please. In G1, the number of chromosomes equals?
2N.
In S, the number of chromosomes equals?
كمان 2N.
In G2, the number of chromosomes equals?
2N.
In M1, the number of chromosomes equals?
N.
Beautiful. Thank you. Yumna.
Yes, good morning, doctor.
Good morning.
Which is true concerning chromatin? A, only heterochromatin but not euchromatin contains the proteins and DNA. False. Chromatin can be found in cytoplasm. False. Heterochromatin is more condensed than euchromatin. True. D, constitutive heterochromatin can be transcribed. False.
Okay, and let's clarify for your colleagues why A, B, and C are false. A.
Heterochromatin and euchromatin both are segments of the gene, and they are DNA, so they contain proteins in DNA.
But why did you specify إنه they are segments of genes؟ مش ضروري أبداً. عندك part of heterochromatin that does not contain genes. ليش رحتي بس على genes؟ ليش ضيقتي على حالك هيك؟ It's DNA. ما ضروري أبدا يكون جين. So there are
They are
7.
part of chromatin, which is DNA, yes.
Okay, so say that again correctly.
Both heterochromatin and euchromatin contain proteins and DNA because they are part of the DNA.
Yes. Okay. B.
Chromatin can be found in the cytoplasm is false because chromatin is part of the DNA which is found in the nucleus.
Can it be found in the cytoplasm like the case of bacteria?
Yes.
Do bacteria have
At the
chromatin?
center.
Do bacteria have chromatin? Yumna. Do bacteria have chromatin? Do we talk about chromatin in bacteria?
No.
So that was a tricky question. Be careful, okay?
Okay.
So it's only for eukaryotes. Obviously, heterochromatin is more condensed than euchromatin. Okay, and what about D?
It's false because consecutive heterochromatin is not transcribed. For example, we have the centromeres, which are not transcribed in DNA. Yeah.
You want to say, yeah, I will help you. You want to say that consecutive heterochromatin is not associated with coding sequences. We do not expect to get genes in these areas, so that is why they are never transcribed.
Okay, thank you. Doctor, before we move on, when can I ask something not related to the exercises?
It's about lectures, it's about genetics, yani?
Yes, of course, about the previous chapter.
Yeah, sure. When will it be done today, inshallah, إذا بقي معنا وقت. Be my guest. Okay, let's see مين معي هلا. Okay, other hands, please, other than Sarah or Hawda or... Okay. Should I call on your names, please? Like Ahmad Hamoud, are you there? Or Ali? Ali Aqil, are you there?
Doctor, I'm another Sarah.
Okay, I'm sorry. Okay, so we have, كلهم girls today. شو القصة؟ ما في كلام معي إلا عمر الصبح. Okay, so we have Muhammad تشجع, okay? So we have Sarah, and then we have Mira, queuing, okay? احفظوا أدواركم. Sarah, and then Mira, and then Fatima, and then Muhammad. Yalla, let's start with Sarah then.
Okay. Deoxycytidine is a DNA nucleotide true. RNA nucleotide false because in RNA it is called cytidine. Nucleoside of DNA with the base is cytidine false because it is called deoxycytidine in DNA. Nucleoside of DNA with the base is cytosine. Cytosine is the nitrogenous base, not the name.
Sarah, let's do this together, okay?
Yes.
Deoxycytidine is a DNA nucleotide. What's a nucleotide, ya Sarah? Give me the definition of a nucleotide. Sarah, are you still there? Okay, طيب يمكن عندها مشكلة. DNA nucleotide, this is when we have the sugar attached to the
plus
base.
the phosphate.
Yeah, plus the phosphate. We don't have a phosphate here, so that's not a nucleotide, okay? It is DNA based, but it's not a nucleotide. Not RNA, because deoxy, whatever is, it's not in RNA, so forget about B. Nucleoside of DNA with the base is cytidine. Okay, it's a nucleoside to start with. Of DNA, it's DNA. With the base is cytidine. The base is not designated as cytidine. It's the nucleoside that is designated as cytidine, okay? It is a nucleoside with having a base as cytosine. That's correct. انتبهوا لهم هول nomenclature كتير مهمين لأنه they can be tricky for some students. بدكم تتمرنوا عليهم إذا عندكم weakness points فيهم. Okay? Good. Thank you, Sarah.
دكتور يعني لو
أما
the name
دكتور شو قلت الفرق بين السايتوزين والسايتوزين؟
هيدا nucleoside designation. هيدا البيز. هو دارسينه.
بس ما هن قايلين فوق النيوكليوزايد كمان.
عم بيقول لك a nucleoside with the base. عم يعطيك إياها complete هون. بيقول لك هذا nucleoside having a base as cytosine. مظبوط. شو الغلط بالموضوع؟ هون عم بيقول لك a nucleoside البيز is cytidine. لا مش البيز cytidine. هي cytidine. البيز cytosine.
اوكي ماشي.
Mira. Yes.
It's just a question before you skip. If the naming was added on it 5' phosphate, will you consider it as a DNA nucleotide?
If the naming is what?
يعني عندنا deoxycytidine 5' phosphate.
أي.
Then we consider it as a DNA nucleotide.
Yes. Okay. Sure. The phosphate is incorporated على 5' صار nucleotide ساعتها.
Okay.
Okay. يلا ميرا.
Yes, doctor. Amino acids A are attached to the 3' end of tRNA. It's true. Are translated on mRNA in the 3' 5' direction. False. Are all specified by many sense codons. False. Attached to the site E of the ribosome during translation. كمان false. B false لأنه 5' 3' direction synthesis بتصير. C مش كلهم by many sense codons بس في 18 من أصل 20. D they attach أول شيء الانيشيتور بيتبلش على البي بعدين بيصيروا بالA charged tRNA.
Okay. Actually, during the translation, the amino acids are never found in the E. Never. Because basically لما بيفوت ال tRNA على E بيكون uncharged. So you never find amino acids attached to a tRNA in the E site. To make that clear, okay, once for all. في another way to represent C actually حتى إنه إذا مرق معكم هيك description ما تلاقوها كتير complicated. فينا to rephrase نقول مثلا or are specified by many sense codons عم بتصير all are redundant بتطلع غلط. all are degenerate بتطلع غلط. some of them are redundant بتكون مزبوط. لما بنقول redundant يعني they do have more than one sense codons that specify them. Okay, نحن قلنا في اثنين هن they are not redundant يلي هن الميثيونين والتريبتوفان. You can find them actually بالgenetic code table and you will be provided with these. حيكون عندكم إياه للgenetic code table with all the codons sense و nonsense. So بكل بساطة رح تقدر تشوفوا إنه الميثيونين والتريبتوفان هن عبارة عن الامينو acids that are not redundant. Okay, thank you Mira. Very good. Fatima.
The following amino acid sequence corresponds to a DNA sequence that corresponds to the beginning of a gene. Then the DNA sequence is made up of at least 4 nucleotides. كل codon consists of 3 nucleotides. أنا هون طلع معي 2.
فاطمة عم يسأل على الدي ان اي سيكونس كلها هيدي اللي بتعطينا هيدي السيكونس للامينو اسيدز. عم يسأل
اوكي is made up of 4 sense codons.
خلينا لحظة ليش هالقد عم تسرعي؟ خلينا A B مثل ما اشتغل رفقاتك A B C D A.
اوكي A يعني is false لأنهم عم يسألون عن amino acid sequence.
عم يسألوا على الدي ان اي
sequence. will be consists of 15 nucleotides كمان نفس اللي فوق.
قصدك إنه
C is made up of 4 sense codons. That's true because every amino acid specify a codon. As every codon specify an amino acid. فهون أنا عندي 4 amino acids no that's true.
Okay.
D is made up of 5 codons. That's wrong لأنه أنا عندي 4 amino acids only فعندي only 4 codons.
What about stop codon?
I don't have stop codon here.
Why?
لأنه الstop codon ما عنده doesn't specify any amino acid.
بس شو عرفك إنه ما في stop codon بالmRNA؟
إنه قصدك إنه يكون عندي وما حاطين لي amino acid عنده صح؟
عم بسألك كيف بنعرف؟ فينا نعرف؟
لا I don't know.
Okay. Let's start. لحظة خلينا مع فاطمة please. A is made up of at least 4 nucleotides. It's far away from the true number of nucleotides. At least 4 nucleotides. It doesn't make sense أصلا كل الجملة على بعضها هو منها الضابطة يعني. أكيد مش at least 4 nucleotides يعني. Consists of 15 nucleotides. هيدي it brings us to D كمان لأنه they match actually. كأنه عم بيقلك إنه انتبهي بلكي on top of the 12 nucleotides اللي هن عبارة عن هال 4 sense codons you have the stop codon بصيروا 15 معنا. So إذا أنت منك متأكدة من الدي كمان رح توقعي بالبي. C is made up of 4 sense codons. Okay, fine. كتير منيح. في عندك actually an underlined 3 words beginning of a gene that you know makes things clear for you. اللي عم بقولك إنه beginning of a gene يعني there's no way يكون عندك stop codon بال beginning of the gene. So حلت لنا البي والدي خلص ما بقى لازم تكون puzzling لنا لأنه ما في عنا stop codon so that we only have 12 nucleotides and that corresponds to 4 sense codons and we don't have then 5 codons.
Okay.
Good. Fatima. Hamad. كان محمد بده يشارك معنا غير رأيه؟
بلا هي موجود
Okay.
سمعتك أول.
يلا.
Which of the following statements about the anticodon is correct? It involves 3 hydrogen bonds with the codon. It lies on the non-coding strand of DNA while the codon is the coding strand. The genetic code consists of a series of anticodons. Each anticodons correspond to the same amino acid.
Okay, Muhammad. Which is correct?
It lies on the non-coding strand of DNA.
Do we find anticodon on the non-coding strand of DNA? That's what you've chosen B. You find an anticodon على DNA. طيب, okay. Hamad, please stay with us. Stay with us and listen carefully to the correction, okay? طيب. خليني أشوف other hands. Samir?
Yes, teacher.
Hello, yalla, please. Can we do 11?
It involves 3 hydrogen bonds with the codon. It's false. It involves 6 up to 9 hydrogen bonds.
Excellent. B.
It lies on the non-coding strand of DNA, while the coding is on the coding strand. It's false. It lies on the tRNA.
Okay. هلا, while the codon is on the coding strand, actually you can find the codon on the coding strand. مش غلط هيدي, بس نحن هون أثبت إنه نحكي على mRNA لأنه الهيدروجين بوندينج بين الانتي كودون بتكون مع الكودون على mRNA, not on the coding strand على DNA. Okay?
C. The genetic code consists of a series of anticodons. It's false. It consists of a series of codons.
Bravo. D.
each anticodon corresponds to the same amino acids. It's true.
برافو. اوكي. يعني اللي بيحدد شو هو الامينو اسيد that's gonna be attached على 3 prime ل tRNA is the anticodon domain يلي هو بيتعرف على الكودون على هال mRNA. Very good سمير.
دكتور بس بي صح ولا غلط؟
بي؟
يس.
بي غلط. ما قلنا انه منا على الدي ان اي، هي على تي ار ان اي. انتي كودون عم يسألك عن انتي كودون. Who is this محمد؟
لا علي بس عم بسأل سؤال.
ايه يا علي؟ نو عم نشتغل انتي كودون so that's on the tRNA.
ايه بس ما هو كاتب من الانتي كودون على النون كودينج ستراند.
ايه مش هناك بقول لك it's false، عم يسألنا على الكوريكت هو.
اوكي.
دكتور كيف عرفنا انه من 6 ل 12 هيدروجين بوندز؟ ما هو حسب النيتروجينيوس سبيس انه
ما قال 12 في
من 6 ل 9.
6 ل 9
up to 9 yes. اوكي مين بده يعملنا 12؟ 12 is beautiful. غير بتول. أحمد you raised your hand قبل شوي. شباب هلا بقول الصبايا بهاي القاعة أشطر من الشباب، كان عندكم عطلة. they are very well prepared الصبايا. لا some of the guys are بس إنه مش الكل. نصر or نشأت.
صباح الخير.
يا هلا. فينا نعمل 12 نشأت؟
ايه أكيد.
يلا تفضل.
Cystic fibrosis is an inherited autosomal recessive disorder. The diagram below shows both alleles, the normal allele, the above strand, the mutant allele that causes CF, the lower strand. What could you conclude from this? Part C will true. A مش nitrogen space will deleted. لأنه هن 3 راحوا.
ايه اوكي نشأت. let's do that systematically مثل ما كنا عم نشتغل انا ورفقاتك. so start from A please.
A nitrogen space was deleted in the sick individual.
Okay, is that
false انه هني الكودون راح 1 كودون.
راح عنا 3 bases.
3.
Yes. Okay, it's not one nitrogenous base, rather we have the deletion of
BHE.
We have the deletion of 3 bases.
3 bases. فبي هي غلط. مش replaced، هي deletion عنا.
Yeah, so that B, the cytosine was replaced by a thiamine in the sick individual. That's wrong. Okay, C.
An amino acid has been lost in the sick individual. هيدي true.
Yes.
The mutation is silent. False. and صار في عنا change بالsequence.
This is not why it's silent. We can have a change in the DNA and a change in the RNA, and we still have a silent mutation, right? This is not how we correct D. It cannot be silent simply because this is a deletion of 3 bases. أصلاً إذا كان عندك deletion whatsoever شو ما كان عدد ال deleted bases, it's never silent. هيدي بتروح للpoint mutation substitution type. نحن the case that we have for the cystic fibrosis in this exercise هي the deletion of 3 base pairs. So can we correct D, please?
The mutation is missense mutation.
نشأت ركز معي شوي please. عم نقول عنا deletion ل 3 bases. Can that be a missense mutation? شو المسانسة؟
هي in frame هيدي.
اوكي سو ذات يعني حتى don't mix things up يعني بالسنس اللي علاقه بالسبستيوشن نحن هون عم نشتغل deletion هيديك شغله هيدي شغله اوكي طيب it's what شو قلت لي؟
هي in frame
in frame what؟
in frame shift
كيف in frame وشفت؟ كيف يعني انت اليوم عم تجمع لي apple with banana او يعني اجمع لي الاضداد مع بعض، كيف طالعه معك in frame وشفت؟ هي يا frame shift يا اما in frame، هول بعض عكس بعضهم، يا اما the frame is maintained بقول انا in frame، يا بقول frame is shifted وموضوع تاني. طيب ليكم ما اجمل هالديمونستريشن حاطط لنا اياه هون خليك معي يا مشقط، بس على كل الاحوال انت لحد هلا اتس جود يعني غلطت اخر شيء معي بقصه يمكن ضاعت كان بدك تقول لي ان فريم ديليشن بدل ما تقول ديليشن قلت لي فريم قلت شفت. شباب وصبايا بليز طلعوا معي هون حاطين لكم اياها هذه not for nothing actually it's so beautiful. عندي الاي تي سي طبعا فرجيني هون على الوايلد تايب الليل and this is the coding strand of the wild type قايل لي انه على البوزيشن 507 so that's the sense codon number 507 I have isoleucine designated or specified by ATC على ال DNA AUC على ال mRNA. على 508 I have phenylalanine and this is specified by TTT or UUU على mRNA. الجلايسين على البوزيشن 509 that's specified by GGT على الكودينج strand of DNA or the GGU على mRNA. alright that's the wild type اللي كتير منيح. I have فإذا isoleucine phenylalanine glycine. بيجي على الميوتنت الليل شو صار عندي هون أنا؟ على 507 I have actually كان عندي ATC this box shows the deletion beautifully عندي CTT C من أول كودون هي actually the third nucleotide وعندي أول اثنين من الكودون يلي وراه دغري that makes إنه 3 base pairs deleted. عمليا شو بيصير عندي؟ Is this a frame shift or an in-frame deletion؟ بالمبدأ it's a multiple of 3 to start with. طيب ATT إذا بروح على الجينيتيك تيبل رح يطلع معي أنا إنه ال ATT designates also isoleucine so that بقي عندي نفس الأمينو أسيد هون and then we have the GGT وراها glycine so that عمليا what happened is we have the loss of phenylalanine at the position 508 so that's an in-frame لأنه لا اللي قبله تغير ولا اللي بعده تغير it's just this phenylalanine that has been lost. So to correct deep or the mutation is an in-frame deletion. Is that okay? نقص عندي 3 nucleotides على DNA 3 nucleotides على ال mRNA and 1 amino acid على ال peptide. Okay نشأت؟
Okay teacher.
Very good. بهمني تتعلموا من المستيكس make mistakes ما عندي مشكلة أبدا بس بهمني نتعلم من المستيكس and let's make a re-recording.